Hi, everybody. I'm going to do a short presentation of a script that replicates a graphic that saw the other day in The Economist that calculated the population in Iran and other regions, but I'll just do Iran, affected by missile strikes. So defined affected as those within a kilometer of a missile strike. So we simulate some data on missile strikes in Iran, calculate a radius of 1 kilometer around each missile strike, the latitude and longitude of each missile strike. And then we overlay that on a gridded population map of the population of Iran. And then we calculate the intersection of the circles defined by the strikes and the underlying population. We have to take into account that some of the population data is gridded, and some of the grids might just be touching the circle. Only a little bit of the grid is in the circle, so we weight it by the area. We weight the population by the area of the grid that's actually in the circle. It's one way to do it. If we had even finer gridded population data, we wouldn't. We'd still have to do that, but be less important. And then we add up all the population affected by that for every day over the, say, 30 days of the U.S. war in strikes on Iran, and that'll give us the graphic. So let's get started. What we have here is our studio, and I've already prepared a script for this. So I'm just going to load in the script, and then we'll just talk through it. And I'll give you all a link to the script. I'll put it on my GitHub so that you could download the script yourself if you like. And I'll put that in the comments of the video. So let's before that, I'm going to pause for 1 second and find that graphic. Okay, I took a second and I found the graphic. Here's the graphic. So we see the title's cumulative population of areas within 1 kilometer of the strike. We're just going to do the red for Iran and not worry about strikes on other countries. On the x-axis, we'll have the dates, and we'll just do the cumulative population of the areas within 1 kilometer of the strike. So pretty straightforward graph. Take a look first at this graph. Notice that if you start thinking about the graph, there's a whole bunch of questions that might arise that are choices that we as analysts would have to make. And it's good exercise for you to think about what are some of those choices. But let's get back to our script then. We can close this down. So here's our script. We have a bunch of packages that we're going to load, and these need to be installed on your computer, of course, beforehand. So hopefully you've installed them, and then we load them with the library command. Then we're going to clear the environment, and then just for fun, because I want to see how long it takes me, I'm going to set the T1 to be the system time so that we have an idea how long it takes me. I'm going to be walking through this. The whole script, if you just run it from start to end, takes about 40 seconds on a typical computer. It depends on, your computer's ability to access these downloaded files that we're going to do. So we need two downloaded files. We need a shape file for the border of Iran, and then we need the gridded population map for Iran. The shape files, there's many different ways to get the shape files for the border of Iran. We will download them from gadam.org, and we're going to download the shape file for Iran. That'll then show up as a zipped file. And if we, just to show you how you can do it, we'll go over here to Gadam. So there's Gadam. We go to data. We go download spatial data by country. Uh, we can type in Iran. Well, no, I guess it does it just with one. So there's Iran, and here's the shape file. So that'd be the one we'll use. So we download that. It'll download as a zip file, which you then have to unzip on your computer. So that'll be the shape file. Then the command to read in the shape file Once you've downloaded it, you have to give it the full path to wherever it is, and you just tell it to read the file that's called .shp, the shapefile at the end. It'll then read in the other files. There's 6 files, I think, associated with a shapefile. It'll read in the other ones. And then we'll get the border of Iran. And I give you some other commands here. You can explore them. And then we can use tmap to map this border. And that certainly looks like the border of Iran. So we've got the border. Now we need to download the gridded population map for Iran. And that comes from the, I can't forget what it's called, gridded population map of the world. It's there's a R package called geodata that uses the population command in that package that will go to that gridded population map of the world data set and download it. We can download it for different years. We'll download it for 2020. We'll do the resolution of zero point 0.5 arc, I think it's arc second, arc minutes maybe, which is a way of representing area on a curved surface. And we'll tell it we want the International Standard Organization 3-letter abbreviation IRN for Iran. And then we'll tell it where we want this data to go. I'm going to put it in my downloads folder. And we'll call this the zero point 0.5 resolution. We can also do the 2.5 resolution, which will be much, much bigger and smaller than number of areas. So I'm going to do it here with the 2.5 one because that, even though it's a much higher resolution, it's just smaller and it's going to be faster. So I've downloaded that. You can go ahead and download that. Then I save the file as the file is called a raster file because it's just a picture of pixels and each pixel has a color. And then we convert that raster file into a TIF file and save it. So you can see here we're saving it as a .tif file, both of them, the 2.5 and the 0.5. And you can see the sizes of these files are quite different if you do this. And then we'll read in the raster file, the .tif file. So this will be a gridded population map. So if I run this, I think, yeah, there we go. There's the gridded population map. I'm going to crop it to the border of Iran. The population map includes, I think it comes as a square for the northern, southern, eastern, western boundaries of defined by Iran. So we just want to, we don't need all those other pixels that are in the square. So we just crop it to the border of Iran. So we have that. And then we're going to turn it into the standard for mapping that we'll use for geometric data, geographic data as simple features. So we'll turn it into a simple features data set, and that's a simple command called as.polygons, which will turn this raster file, this TIF file, into polygons. And then we'll give it a projection system to draw a 3-dimensional map on a 2-dimensional surface, the CRS. You need to Google that, see what all that means. So we'll turn it into polygons, which takes a minute. Then we'll set the coordinate reference system. We'll check that it is indeed a simple feature. So we use the class command, and class indeed is df. And then we'll draw the map. These are you can see it's 91,000 polygons, 91,000 areas. Because it's going to draw 91,000 little areas, and each area has a little border, and the border is black. When it does draw it, it's just going to look all black. There won't be anything. We won't see anything. I guess actually I'm just drawing the borders here. That's why it's all black. Yeah, yeah. I guess if I drew the polygons, yeah, it'd probably still just come out all black. Okay, then we're going to so the population data that comes in the geodata is the density per square kilometer. These areas that we've downloaded are all different because they're defined by the curvature of the Earth. So we need to turn those areas into two-dimensional polygons. So here's some code that I got and did not check. Seems reasonable to me. It's from one, I think Gemini or Claude, how to convert from the arc minutes seconds to standard area using the Earth's radius and all this jazz. So if you like, thinking about mapping systems and taking curves and projecting them onto two dimensions, then this will be fun for you to work through what exactly is the geometry that's going on here. For now, I'm not going to worry about it. Instead, we're just taking the population density and multiplying it by the area of each of these units of area. So that'll give us the population count for each one of these areas. So if we look at DF1 now, we have the longitude, latitude, and the population count of this. This is the centroid of the area. And then we're going to, let's see, remove these things that we don't need. And then we'll just sum up all these 91,000 areas. What's their population? We get 81,798,156, which I think is reasonably close to the population of Iran, which I think like 90 million now. So it's reasonably working. Send me any improvements to this. I'd be happy to put them in the comments. So we are now going to bind this, we're going to column bind. We have our simple features data frame, and now we're going to have our population count. So we're going to bind the two together and call that pop. So now we have 91,000 observations, five variables, we have the population count. And let's make sure that this pop is indeed a simple features. Now we can map this. We'll map the color of each area on a scale. We'll use this Brewer YLORD OR underscore RD scale. It's a color scale. We'll top code the population so that everything above 5,000 is the same color. And the reason for that is because most countries like Iran are enormous sort of empty areas and then huge populations in cities. If we didn't top code it to 5,000 for each area, we'd end up with almost the entire country being the same color and just a few cities being different colors. And we want to indicate sort of more of a spread. So we top coded at 5,000. Remember to know that. So here's the and you can see the syntax here. We take population count. If it's greater than 5,000, then it's going to be 5,000. Otherwise, it's going to be whatever the population count is for that pixel. And then we get, it's not the best map in the world, but we get an idea of the population distribution of Iran there, with coastal areas being denser and Tehran being denser. So we've got our map of areas with population counts, and now we can generate some random strike data. So we'll set a seed so that it can be reproduced. We'll sample within Iran borders. We'll sample 100 strikes. We'll check that this strikes data is simple features. It's not quite simple features, so we'll um, turn it into a simple features. And if we do class now, we'll see that it is indeed SF. Then we're going to generate some random dates between February 22nd and March 31. And we'll just sample 100 of them so that our strikes now, we have our geometry for our strikes points, and then we have the dates for the strikes, so random strikes. We could draw where these strikes are with our T-map. So there's our 100 random strikes. Now what we're going to do is convert our strikes to create, we'll convert it to a metric projection system. You should read about ask Google, what's the difference between CRS 4386 and CRS 3857, and learn a little bit about that. We're going to convert everything to a meter projection system. We're going to calculate a buffer around each strike, a buffer of radius 1,000 meters, 1 kilometer. And then we're going to intersect these buffered strikes, we'll call it points buffered, with the Iran border projection so that we only have strikes, we only have the part of the strikes that are in the border. You can see some of the strikes are right on the border, so their circle that's buffering around it, part of it won't be in Iran, so we want to cut that out. And we can map those, but mapping them, frankly, won't be very interesting because this Iran is a pretty big country, and little 1 kilometer circles will just show up like little dots on the map because there's hundreds or maybe 1,000 kilometers across. So these little circles of 1 kilometer radius are not visible unless we really zoomed in. So here's a little aside to zoom in. We'll just zoom in around Tehran. I'll not explain it. I'll let you look through it. So here's Tehran, but even Tehran, we have 250 kilometers. So each one of these circles is 1 kilometer. So imagine there's 250 little pixels here. We can see we still can't really see the circles because they're just very small in radius relative to the area we have. We could put the buffer around Tehran to be much smaller, and let's see. We don't know if there will be a strike within that area. Um, yeah, see, that's the trouble with this. We then didn't get an actual strike within that. Let's try a slightly bigger radius and see if there's a strike within that area. We just randomly generated the strike, so even in this one, there's still no area. And then let's do, so I think we did 250, so we're back to that again. But now we have a really big bounding box, so the things are pretty small. Anyway, it's fun to play with that. So we have our circles. We will turn our circles into metrics, turn our population into metrics. 3857 is a metric projection system. And then we'll calculate the original area for each one of the area units. And then we're going to intersect the population areas with the strike circles. And then we're going to calculate the population inside the circle as the population count of the area, but with the ratio of how much of the area is inside the strike circle divided by the original area of the population um, area that we have. So that'll give us the population in each circle that's affected, and then we can uh, calculate a new data set. We'll call it pop strike date. We'll take the intersections, we'll drop the geometry, we'll group by the date. Then we'll add up for each date the population the adjusted population for the area of the population area that's actually in a circle on that date. We'll add those all up. So we'll use the sum command, and then we'll create a new variable that's the cumulative sum. So ordered by date, how much, what's the cumulative uh, population affected by the strikes, and then we'll use ggplot. We set the X to be the date. We set the Y to be the cumulative pop. We use geom_bar, which has this weird syntax that we're just going to want the cumulative pop. So whatever we represent on the bars is just what the value is. And that gives us then our cumulative population affected by the strikes. And this looks very much like the Economist map. We could turn it red. We can do all kinds of options. I'll leave that as an exercise for you. And before I do anything, let's clear the environment here and clear this. And then let's highlight the whole area, and we'll be able to see then how long it takes, because how long it takes to run the whole script will be T2 minus T1. So I said earlier it was going to be about 40 seconds. We'll see if doing it this second time is also about 40 seconds. I think it's fun script. interesting to sort of explore. You can always try this out for a different country. Imagine that Spain or um, uh, uh, South Korea were under attack. What would be the population affected by a random set of missile strikes? You can do those calculations. So there we see it's going through. It's almost at the end here. Um, and we'll see how long it took to do this. 48 seconds, so about the same. Hope you found this interesting.